It's your own logarithmic equation, and this is explanation for GCSE, iGCSE. So that might be probably the hardest topic for understanding how to solve logarithmic equations, but the clue here is to awareness of the main logarithmic rules. So before we're doing actually logarithmic equations, we need to be able to make rearrangements, and you need to feel free to do that, to be very confident. So that's why, first of all, let's discuss how to do it for specific examples, and later on we just go to equations itself. All right, so we need to write the following equations as the logarithmic ones in the base 10. As you remember, we mark as just log. It means that if the base is skipped or missed, it means the base is 10. Okay, how to write this one as a logarithmic in the base 10? So easily, we just apply to both sides log, as if you're like multiplying everything to both sides of the equation by 2, but instead of multiplying by 2, you just apply log to two parts, the left hand side and right hand side, with a base of 10. So in this case, if you apply that, you'll get log with the base 10 of y, and on the right side you'll get log x4 and z5. Now just remember, we can apply a log of the product, and this is the rule that we are actually applying here, and in this case we'll get a formula. So log y will be equal to log x to the power 4 and plus log z to the power 5. And just right now, we are going to simplify that. That means we can write as the following. So again, applying the property or logarithmic rule, we can take this power and simply put before log itself, as well as here. So again, this is all about logarithmic rules. So that's why we put 4 before log, and finally we've got 4 log x plus 5 log z. Okay, so I hope you got it, and again, that's based on logarithmic rules, so that's why you need to know that. Just make a reference to the video where you can find logarithmic rules explained and actually proved, so make sure you understand how it works. And let's get to the same question, almost the same, and apply the same strategy. So to both parts we're going to apply log, and that makes the left hand side log y. On the right hand side I just have a little shortcut, so I'll already write as log square root of x and plus log z cubed. Okay, so that's why left hand side stays the same and right hand side. So you remember that x square root of x is the same as x to the power 1 over 2. So in most cases it's easier to operate with powers instead of using roots. So once have your power here as x 1 over 2, you can apply the property, and again what we were doing here in the previous example, we can put 1 over 2 as the coefficient before log, and we'll have 1 over 2 log x. And the same for 3 here, so we put 3 before log z. So that's the final logarithmic equation, which is an equivalent to actually the initial one. All right, let's consider the next questions. We need to write this equation without logs and make y as the subject. Okay, so let's have a look at the first one. So we have log x squared log equals to log y minus 6 log x. Okay, we don't need to use logs here, so that's why what we can do, the basic approach is to get log, because the base are the same log as base 10, so we should make something like log with the base 10 of a equals to log with the base 10 of another number b, so that right now we can say that a is equal to b. So we can apply this approach here and we can write, so log x squared equals to log y minus 6 log x, I just rewrite as log y minus, and 6 goes back to the power of x, so I just write as log x to the power of 6. Okay, and now what I can do, I can use again rules for logs as the difference of logs. That means it actually becomes division of y by x to the power of 6. So that's why I'll get log x squared, and that will be equal to log of the fraction, whereas the top is y and the bottom is x6, x to the power 6. And now, using this approach, we can get a equals b, so that's why instead we will have x squared equals to y over x to the power of 6. If you rearrange that, we can write in a different way, so we can say that if we multiply both parts by x to the power 6, we'll get x to the power 6 equals y. Okay, but we need to make y as the subject, so it's better to write like this: y equals to x to the power of 8. Sorry, 8. Okay, so that's why we actually expressed. So that's the main idea, and this is the main principle that we apply here. So let's try to do the second one. We've got 2 log x, so that's why I just lift up the 2 as the power, so we'll get log x squared will be equal to 1 over 2, we again lift it up as the power, and we'll get log y to the power 1 over 2. And 3 we also lift it up, so that's why we will have log x cubed. Alright, and now we again use the properties and try to combine log y 1 over 2 and log x cubed, so using the rules for the sum. So what we're going to do, we can say that log x squared will be equal to, instead of y to the power 1 over 2, I will use square root of y. So that's why finally we will get square root of y times x cubed. So x cubed is not under the square root, and this becomes the number inside the log. Now, using the property a equals b from logs, we can say that x squared is going to be square root of y times x cubed. So that's why finally we can, not finally, but almost the last step, so we can say that x squared is going to be equal to square root of y times x cubed. So here is square root of y, we need to express it first, so that's why in the bottom part we will have square root of y will be equal to x squared over x cubed. And as you understand, we can cancel, because obviously in the original expression, so by definition of what log is, we can say that x as well as y is going to be more than 0, so y as well. So that's why we can say that we can freely cancel, and finally we will have y to be equal to, so y is equal to, and here we cancel, so that means we have 1 over x, and then we square it up, so that's why it's going to be 1 over x squared. So that's the final that we have here, so y equals 1 over x squared. I hope you understand how it works, and then we go to the next one. So let's move to the next one. You need to write these equations without logs. Okay, so I hope it's pretty easy right now. So a we lift up here, so that's why we'll have m to the power of a, and here we use the property of addition for logs, so that's why it's going to be log, and here we have multiplication a times b, or ab. All right, so without logs, yeah? Oops, my bad. Actually, I said that I raised the power, but I forgot to write log, sorry. So log m to the power a will be equal to, here we just adding them using this property or rule for addition of logs. So that's why this part stays unchanged. I mean, as I wrote previously. And now we use the same log a equal log b, so we can state that a equals b. So that's why m to the power a will be equivalent to ab. Okay, so that's the final statement here. Okay, so what about log m 1 over 2 log n? Let's try to do the same stuff. So first we'll get log m plus log and n will get the power 1 over 2, but I'll write like square root of n. And on the right side, 0.5 log p. So 0.5 is going to be the power for p, but this is the same as 1 over 2. So that's why we'll get log p to the power 1 over 2. But I would better to write the square root of p, okay? So again, we add in m. So we add in two logs with the same basis, so we can multiply m and square root of n. So we'll get log m square root of n, and that will be equivalent to log square root of p. Okay, yeah, so I know that's a little just okay, so but it works this way. So finally, if I get rid of logs, I'll get m square root of n equals to square root of p. And that's going to be the final result or final expression for the bottom example. Okay, so that's the final expression. So I hope you understand how it works. I hope you understand. So that was the basics for logs. Before actually we doing solving any logarithmic equations and exponential ones. So make sure you understand this practice and also try to make revision by doing another exercise that you might probably have, or just you can do revision that I provide soon. All right, so thank you guys. That was Daniel Dallas, and see you in part 2.